Hey guys, how's it going? So recently, for about like 6 months, I've been working on a project on density functional theory. So under this project, I got to work with a variety of softwares involving the DFT, that is the density functional theory, and one of those softwares was Quantum Espresso. So Quantum Espresso is an open source DFT package used for electronic structure calculations and all sorts of things, and it is quite popular, and it, due to its open source nature, it did have a lot of like um, limitations or disadvantages, like the input files were a headache to create, and the procedure to run these calculations was pretty complicated too if you are not from a computer background. However, in this tutorial, I'm going to introduce you guys to a thing called BURAI 1.3, which is a GUI of Quantum Espresso. That is, it is a graphical user interface of Quantum Espresso. So it really, eases the process of creating the input files, running these calculations, and everything that was holding Quantum Espresso back has been remedied using this amazing piece of software. Now this software was created by Satomichi Nishihara. I'm not sure if I'm pronouncing that correct, but I would like to thank this person for creating such a amazing piece of software. It is an elegant user interface for Quantum Espresso. So this is a introduction video to this software on how to download and install it on your PCs or Macs, and then we will be I'll be just giving you a brief overview of this software, like what it can do and what it cannot do, and then in the future tutorials I will be covering the more specific parts of like how to perform a specific task or calculation or something like that. So you can download this software from this website. This is the link to the homepage for this BURAI software, and I will add the description to it. I will add the link to it in the description down below, and then you can download it by clicking on resources and then getting the executable file according to your system. So if you have a Windows PC, then you can download it from here, or if you have a Mac, then you can download one for the Mac OS, or if you have an Ubuntu or Linux software, then you can download the executable from here. So, and it is open source too, so you can even view the source code by heading over to their GitHub page. So everything is open and you can easily modify this code according to your needs. So here is the GitHub repository for BURAI software package, and there is all the software codes right there. So just go ahead and download the required executable file. In my case, I'm using a Windows PC, so I already went ahead and downloaded the latest version, that is BURAI 1.3. So once downloaded, you just double click on this folder to open it, and then you go to bin and then just double click on this Java file. Now one thing to make sure is, if you run this file and you run into an error, then it's probably because you don't have the required Java file, because it is built using a Java runtime environment or something like that. So you do need to have a Java package or something like that. So although you don't need to worry, because it usually reminds you of about that, and it just handles the process really automatically. So it is an amazing piece of software. So once you double click on it and open it, then you will see a window like this. However, this part of this window would be empty for you because you are using it for the first time. Therefore the recently used part should be empty. In my case, I've been running several calculations on several systems, so it is showing a lot of recently used projects. So what you will do is that you will click on my projects. In case you're running it for the first time, then you can go to examples by clicking on it. And then what you will notice is it has three kinds of file supports. That is, it supports crystallographic information files, that is CIF. It supports the .xyz files, and then it supports the quantum espresso input output files. So you can double click on any of these, and there are several files already provided or preloaded into the software, so you can just go ahead and double click on any of these files and it will pop up in a separate tab. So here I have opened an FE, that is the iron structure. So once you open a structure, then you can just zoom in or zoom out using the scroll button on your mouse, and you can just drag and move it. So basically, coming to the kind of calculations of what BURAI, this amazing piece of software, can do. So it is amazing, and what it can do is it can be used as a modeler. So it can be used to, model any system, like creating stuff like supercells, monolayers, slabs, etc. And then it can be used to run several calculations like the SCF, optimization, molecular dynamics, density of states, band structure calculations, and a lot of stuff. However, these three features haven't been implemented yet. So if you click on phonon or time dependent DFT or the NEB, then you will see that it shows that these features haven't been implemented. So coming back to the original geometry tab, so when you open it, you see a lot of geometrical tabs. So it makes the process of creating a quantum espresso input file really easy, because you have all this sort of input boxes where you can fill out the fields very easily without worrying about the correct syntax, because as you change these, it directly changes the input file. Now, however, this was just an introduction or a overview video for the software, so I will not go into the deep about all these different kinds of stuff. I will make separate tutorials for all these, so make sure you check out the second tutorial, because I'll be covering the geometry part in that and how to model a system. So I'll be covering each and every part of this software in the later tutorials. However, I do want to just cover two more things. That we just now opened the CIF file. However, it can even open XYZ files, so you can just go ahead and try one of these out, like benzene. Okay, so here you have a nice little benzene structure. Then you can even try to open a lot of quantum espresso input files. Now the good thing is that the creators have provided a lot of input files, like different kinds of calculations. Like here we have a LDA plus U, that is a Hubbard parameter or Hubbard correction calculation. Then we have something like hybrid calculations examples here. So here we have HSE, that is the hybrid calculations. Then we have Berry phase calculations, and a lot of examples have been provided. So really a big thanks to the creators for creating this, because it really did help me a lot in using or working with quantum espresso. So that's all. And one more thing, that this software even comes with a materials API. So in case you want to get the structure for a particular system, then you just need to go ahead and enter that. So for example, I need the structure of CDSE, then I just enter that here and press enter, and it will automatically connect to the materialsproject.org, which is another very great website for these simulation kind of stuff. It is a great database, so it will already automatically connect to that and provide with the available crystal structure file. So here we have the hexagonal or the word side structure. Here we have the cubic zinc blende structure, so you can just go ahead and double click on it and it will open here. And once you open that by double clicking on it, then it will show up in your downloads tab. So I already have a lot of stuff here because I've been using this software for quite some time now. So I'm not sure where this latest file that I opened went. Maybe it will come here once I save it. Alright, so that's just a overview or an introduction video. I hope you guys liked it, and do watch my next tutorials, because I'll be covering a lot of stuff about quantum espresso and use how to use it with BURAI. So well, that's it. Thanks for watching. If you like this video, don't forget to hit the like button and subscribe to my channel for more videos like this. Thanks for watching and have a great day.